Every time you turn the key and hear that roar, an incredible chain reaction unfolds under the hood. But, have you ever wondered how your car's engine actually works? How does a few drops of fuel generate enough power to move a 4,000-pound machine at 70 miles per hour? Whether you're a car enthusiast, an aspiring engineer, or just curious about what's happening inside your ride, today we're breaking down the magic of internal combustion, in the simplest way possible. And trust me, by the end of this video, you'll never look at your car the same way again. At the core of your car's power lies the internal combustion engine, a mechanical masterpiece that converts fuel into motion using a series of controlled explosions. Think of it like this: your engine is basically a high-tech air pump. It pulls in air, mixes it with fuel, ignites it, and then pushes out exhaust gases. But the real magic happens in the heart of the engine, the cylinders. Let's zoom in and see what happens inside these metal chambers. Your car's engine operates in a four-step cycle, happening in milliseconds but thousands of times per minute. Intake stroke. The piston moves down, pulling in a mix of air and fuel. Compression stroke. The piston moves up, squeezing the mixture into a tiny space. Power stroke. A spark plug ignites the compressed fuel, creating a tiny explosion that forces the piston down. Exhaust stroke. The piston moves up again, pushing out the burned gases. And just like that, your engine comes to life, repeating this cycle over and over, turning chemical energy into motion. The pistons are the workhorses of the engine, moving up and down inside the cylinders. But how does that up and down motion turn into the smooth rotation of your wheels? That's where the crankshaft comes in. Think of the crankshaft like the pedals of a bicycle, converting linear motion into rotational motion. And then there's the camshaft, responsible for opening and closing the engine's valves, ensuring the perfect timing for air and fuel to enter, and exhaust to exit. Modern engines use a high-tech fuel injection system, replacing older carburetors for more precise control. It's like the difference between pouring syrup on pancakes versus using a medical syringe to deliver the exact amount needed. The engine's computer, the ECU or engine control unit, determines the perfect amount of fuel to inject, maximizing efficiency, power, and fuel economy. But what if I told you your car's engine doesn't actually create power, it just converts it? Your engine doesn't make energy, it transforms it. A gallon of gasoline contains 33.7 kilowatt-hours of chemical energy. But here's the shocking part: only 30% of that energy actually moves your car. The rest, wasted as heat. That's why engineers are constantly innovating, creating turbochargers, hybrid systems, and electric motors to squeeze every last drop of efficiency. Engines get hot, really hot. We're talking over 2,000 degrees Fahrenheit inside the cylinders. If it weren't for the cooling system, your engine would literally melt itself. That's where coolant, oil, and radiators come in, working together to dissipate heat and reduce friction. Ever ignored your check engine light? A small leak or overheating issue can destroy an engine in minutes. And speaking of destruction, what happens when an engine fails? Let's talk about the biggest causes of engine breakdowns. Engines are built to last, but these 3 deadly mistakes can send yours to the junkyard faster than you think. 1. Lack of oil changes. Without lubrication, metal parts grind together, causing catastrophic failure. 2. Overheating. Blown head gaskets, warped cylinders, and cracked engine blocks happen when the cooling system fails. 3. Ignoring warning signs. Strange noises, smoke, or power loss. That's your engine begging for help. The good news? With proper maintenance, a well-built engine can last 300,000 miles or more. Now that you understand how an engine works, imagine what's next. How modern technology is revolutionizing the future of car engines. Watch next, the future of car engines. Will gasoline become obsolete? Like and subscribe for more in-depth car breakdowns and engineering insights. #CarEngine #, how engines work #, automotive engineering #, car mechanics #, internal combustion #, engineering explained.